Hello everyone! To start off, I want to say thanks to viewers who joined our unusual conference. I hope you can enjoy this talk sitting on your couch. Actually, who knows, maybe this forced constraint will become a stimulus for evolution and we will get a new and interesting conferences format. Because video is a limitless source of opportunity, and as a drop of the hat, we can overcome all restriction and quickly move to the originally planned conferences venue, to the Portland. Or we can have a conversation with a famous person from the Ruby community. For example, we can call Aaron Patterson and ask, hey Aaron, what do you think about GraphQL Authorization? Aaron is super friendly and 100% sure he will not refuse us. Yeah, the possibility of online world is truly endless, and platform like TikTok proves that people have immense creativity. However, this is one of our first attempt, and we didn't have long to prepare and record whole video, so I'm going to limit this to a couple of opening slides with my face. So, let me introduce myself. My name is Nikolay Sverchkov and I am creative backend engineer at Martians. We are engaged in product development and help companies such as eBay, Fontaine or 2U to grow their products. We are open source fans and I think you have heard about our front-end libraries such as Autoprefixer or PostCSS, Ruby gems like Anycable or TestProof. Also, we start working on blockchain open source, and now we are developing Astrograph, which is GraphQL interface for Stellar. For more information, you can visit our website at as for me, I am from Tatarstan, and this is a place in Russia you may never have heard of. Typically, I might say the phrase, come to me after the talk and I'll give you cool stickers with evil Martian in national costume from the place where I live. But alas, we have to wait a little for this. Okay, enough about me, let's move to the topic of the talk. It's good form for the speaker to briefly go over the talk and their vision. I know that sometimes when people see GraphQL in the title, they think, okay, yet another speaker will try to sell me GraphQL again and tell me how amazing it is. But that is not why we are here today. I would like to stick to the basic concepts instead of going into a detailed introduction to the technology. Sometimes I doubt the benefits of GraphQL because I see a lot of hype around the technology, and only few say that it's extremely difficult to design a good GraphQL API. I thought that the best way to share my experience with GraphQL authorization is to show a comparison of GraphQL with something that you all know, RESTful authorization, and I'm going to provide specific example of them too. To begin, let's remember what RESTful is. On this slide, you can see the standard Rails application architecture. On the left side is the user, on the right side is our data and layer for interacting with this data, or simply put, active record. And in the middle, we can see API for connecting the user and data. This is architecture that Ruby on Rails provides out of the box, and as I said in the last year's conference in St. Petersburg, I'm a huge fan of DHH and I think Rails is a really great framework. But Rails is just the skeleton for your and our project, and almost always we need more. For example, let's imagine that we have multi-tenant application and somehow we need to control access to specific resources. In this case, we will have to add to the RESTful API another layer and access control layer. So, what is RESTful? RESTful is a software architecture style that defines a set of constraints to be used for creating web services. Okay, but what is GraphQL? GraphQL is a query language for APIs and runtime for fulfilling these queries with your existing data. Yeah, comparing language and architecture style sounds like a terrible idea. To fix this, we are going to introduce the next architecture, GraphQL Rails application. We see in the slide the user and his data, as we saw on previous slides, and something new for us in the middle. If you have never seen GraphQL project before, you may be surprised that in this picture there is only one controller and one row. It might be strange, but it's true. In contrast to our usually very heavy controller folder, we only have one action with a code similar to this. The whole logic of fetching and manipulating data, moving to another place, is something I call GraphQL Internals. And so what is GraphQL Internals? In a global sense, we have one huge class, which is called GraphQL Schema. Schema has one executed method, which takes query and params from request and just execute it. Schema inside consists of two things, types and mutations. This is when types are responsible for read operations and mutations which implement, create, update, and destroy actions. If we look a little closer, these actions are implemented through specific Ruby classes. For example, we can request the user and his profile, or we can request the user, his posts and comments of this post, or just try to add a comment. You can see that all these actions are interconnected and are what? Yeah, you are right, this is a graph. So yeah, and this is all an introduction to GraphQL, what I wanted to give you. So our main question is, how do we implement an access control layer for GraphQL Rails application? Is it possible to reuse approaches from the standard application? And if not, what we need to do? We are going to start with a basic concept, authentication. What is authentication? Authentication is the act of proving the identity of the user, or more simply, determining which user is currently working with the system. To implement authentication, we usually use frameworks such as Device, which has many read-made functions out of the box. The question is, how do we use this framework with GraphQL? Should we, for example, re-implement all device actions such as login or logout using GraphQL? And the answer is no, that is not necessary at all. You can leave your login and logout actions outside the graph and use default device controller. The same idea directly underlies the authorization execution. The biggest mistake will be to transfer not the current user himself, but some token, cookie, or just some identifier to the graph. This will greatly complicate application code and writing tests in the future. So yeah, so far our solutions are no different from the usual RESTful API. Okay, let's move on to a more interesting issue, ensuring authentication. Usually in the system we have two types of actions. Actions allowing everyone, including guests, and actions that only allow it for authorized users. Probably everyone can read posts, but they can only be updated by users who verify themselves. In standard Rails application, we can solve this problem using before action callback. In each case of controller, we set a specific list of actions forbidden for guests. This is not the most maintainable solution, actually, from the point of view of support, but at the same time, it is powerful and easy to use. But what about GraphQL? In the GraphQL version, we have only one controller, and if we protect it with a before callback, it will prohibit all action for guests, which is not adequate. We need to find the solution to prohibit the execution for specific nodes of the graph for unauthorized users. It's time for serious slides and code snippets. Next in the presentation, I'm going to show the code associated with the GraphQL Ruby gem. Actually, I have nothing more to add here because there are no other alternatives in this library in the Ruby ecosystem. Let's take a look at the code we saw earlier. Now we can talk about what context is. Context is a specific variable which is passed along the entire query execution stack. And this is our way to transfer some kind of state. inside the graph. Using the new knowledge, we can look for the example of fetching or getting the user and his profile from the inside. To do this, we create user type class where we define profile field and the method to how to resolve this profile field. Also, we create a profile class and describe the fields that we can request. Actually, everything is really simple. And now, knowing context is available everywhere, we simply add the check of current user just like this. It does not look like hard, does it? And the problem is that this is a purely maintainable solution, and we will have to duplicate the code many times for each resolver. Let's use some magic to solve it. This magic is called visibility. First, I need to say that visibility is GraphQL Ruby specific feature. In the official GraphQL specification, there are no such thing as visibility, and this may be an omission. Secondly, its implementation is simple. We need to add just one method to the type, like here. But we still have a problem of reusing this code. So let's move this method to a separate helper or model and add it to the base type class, just using prepend method. Yeah, it's better, but now a new problem. Such a solution globally affects all types and authenticates the entire graph, but we need it in a place. To fix this, we tweak the types initializer a bit and add saving the login required flag. After that, we can use powerful with option DSL, which is a feature of GraphQL Ruby gem. Using this DSL, we can list the fields that should not be accessible for guests. For example, in this slide, everyone can read users' posts, but the user profile is only for authenticated users. I guess it's really very elegant from my point of view. Visibility is not the only way to implement authentication prediction for specific fields. To understand why this is the best solution, we need to talk about one feature called the introspection system. You can ask GraphQL Schema for information about what queries it supports. There are tools and bots that can build a whole graph based on a given GraphQL entry point. This information about queries, mutations, types, and so on will give an attacker many opportunities to find vulnerabilities and errors in processing in a specific GraphQL implementation. So if you have a non-public API, my advice is to completely disable schema introspection on production. If you write a public API as third-party service, then you can use visibility features that we saw on the previous slides. This automatically hides information about protected branches of your graph. This is all about authentication. Let's talk about authorization. Yeah, authorization is a function of specifying access to the resources. Authentication answers the questions, can this user do this action, or is the user allowed to do this? One of the most common authorization restrictions is based on role. In the application we have administrator, managers, and so on, and we want to restrict access to resources using custom roles. The question is, should we use the same visibility approach as we saw 2 slides back? The short answer is no. It will be a weak decision in terms of application development. The authorization rules are not limited only to the roles of the user. Almost always we have several layers of checks and we cannot cover them with just Boolean flags only. I need to say that there are tools in GraphQL Ruby gem that are designed for authorization, but I do not recommend using them. The problem is that with this approach, GraphQL internal layer will contain too much logic and we will get active record 2.0. In addition, reuse of access rules in other parts of application will be impossible with this implementation. These problems are not new for us, and due to such difficulties with describing access rules, we have several libraries such as CanCan or CanCanCan or Panzit to make our life easier. We would like to continue to use the familiar tools, especially if we are migrating our RESTful application to GraphQL or we have a hybrid architecture and we don't want to rewrite the authorization layer. Let's remember how everything looks for a standard API. For a RESTful API, we are talking about relation with one rule for one action, one authorization rule for one action. Unfortunately, people often get confused about the action. You should think about rule for action of resource, not about rule for action for controller. Yeah, very often these sets are equivalent to each other, but this is only a consequence of the RESTful style itself. The resource-based constraints lie at the heart of GraphQL Authorization too. This is just a little more complicated because nodes of the graph can be not only types, aka resources, but also final scalar fields. And thus we have more opportunities for flexible configuration of access to specific fields of the resources. Which is difficult to do in the standard case, standard Rails application, and it's sometimes solved by duplicating endpoints for different roles, as shown in the slide. So, returning to our original question, can we reuse existing abilities layers? In a sense, yeah. Yes, but at the same time, we will find cases for which we do not have enough solutions. For example, how to pass current user to the policy, how to handle authorization year, how to ensure authorization happens, and so on. Usually, this is covered by helpers, which are part of authorization libraries. The problem is that they are all focused on work with a RESTful application and absolutely not suitable for GraphQL. In fact, this missing part is too important that is sold as a part of a paid GraphQL Ruby version. GraphQL Ruby Pro has integration with CanCan and Panzit. I don't know the exact price of the GraphQL Ruby Pro because I always use free way to solve all the mentioned problems with authorization. Yeah, if you were in a conference room, now I could ask who have heard about GEM action policy and count the number of raised hands, but I cannot do it, and I think that your reaction will be similar to this GIF. For a couple of people who do not know about action policy is Authorization Framework, which is written and maintained by my colleague Vladimir Dementiev. If Pandit library is small and written literally in 200 or 300 lines of code, authorization action policy contains much more built-in features, and this is a framework, not just a library. And in short, action policy is Pandit on steroid, and you can easily migrate from Pandit to action policy. Action policy is independent of Rails and has several extensions, including support of GraphQL Ruby. As I said earlier, policy API is borrowed from the Pandit, and you will not immediately find the difference between them. To use this policy, just add a flag to the specific field, and everything will work magically. We can say the same thing about exception handling. Yeah, you can use similar code with Pandit, but it does not know how to send a specific authorization year message out of the box. Pandit does not know how to do this, but this is important to GraphQL because it is a part of official specification. In general, the library contains manual helpers, which greatly facilitate the implementation authorization for the GraphQL Ruby, but I won't bore you by listing them all. Instead, let's look at more interesting and specific issues. For example, data scoping. In our schema, the user has posts. However, what kind of post we need to return by request depends on the current user. For example, if the current user is the same user, aka owner, he can see all his undeleted posts. If he is administrator, he can see all of the user's posts, including those that are deleted. If he is guest, only published posts can be seen. Just a couple of custom logic. scopes. And as you can see, such a scenario is easily implemented on the policy side. Just 3 lines of code. The main thing is just do not forget to write policy tests. The next feature is even more specific to GraphQL because many people present this technology mainly as an improvement in terms of front-end side. Let's imagine that we have the rule that allows or prohibits a user from performing the action. On the front-end side, we have the button that is responsible for initiating this action. So we need to show or hide that button depending on the rule. Question: where is the best place for UX element display logic? Yeah, unfortunately, many developers choose the wrong solution, and implement the logic in 2 places at once. On the back end, checking the authorization rule. On the front end, the logic of the button display by indirect signs. But the rule is the same, and the right decision is to transfer or expose this information from a single source of truth from the backend. With action policy GraphQL, we can do this with just a single line of code. In this case, the response will look standardized and contain the text of the error in case we need to show why the user is not prohibited from performing the action. It's time for advanced features. One of the biggest problems that I saw in the projects is a performance issue. It's very difficult to design and make GraphQL API without N+1 and batch loading problems. There are also problems that some parts of the graph are requested much more often than others. And in this case, one of the ways to improve performance is to add a cache layer. The cache is required not only for data, but also for calculating the rules, because sometimes rule calculation can be really complicated. And there's this rule of the policy, and in the case of library, editing caching is really simple. With action policy GraphQL, you need just add one single line of code. Attentive listeners may ask themselves now why we are talking only about reading data. What about data changes, or more simply mutations? We didn't talk about mutations because they cannot be nested in GraphQL. Technically, by specification, you can make something like nested mutation, but it's better not to even think about it. In the case of single-layered nesting, mutations are no different from ordinary service objects. One way to cover them with authorization is to call the specific helper in the resolver method, like here. There's only one problem. How do we ensure policies are used? It is crucial to make sure that every change action is protected by policy. This code is not part of GraphQL, Ruby, or action policy, just our custom code. So I will show only the main part of it, and you can find the full code snippet by the link below in GitHub gist. Using this code, we will be protected from forgetful developer, because this after resolver callback automatically will check do we call authorization policy or not. Last but not least, let's discuss writing tests for authorization logic. Unfortunately, for all the modularity of types and mutation declaration with all the flexibility of DSL, at the moment we can only write integration tests. In other words, execute a raw GraphQL query and check the results. This has the advantage that we always check full execution of query, but of course it's not free. Let's look at this simple test for checking permission of a type field. At first glance, everything looks clean. We have several contexts where we check and assess for each type of users. But there are actually bad tests. Like all integration tests, they are slow. We always need to do some setup in the database for each test. They are also complex. We will have to copy-paste the code many times for different fields, or put this code in a shared examples, which does not make the code simpler. And most important, we don't need to check access here at all. For this, we have a different layer of logic policies. Therefore, all authorization logic tests must be in a separate policy layer. For types, we need to only check that the corresponding policy is being called, and action policy GraphQL has helper for this. It is worth noting that all key points from the last two slides are valid for controller tests too. If you add check for each type of user in the controller tests, then I have a bad news for you. Conclusion. Let's time to make a short conclusion. I think you notice that in general we can imagine the whole situation with such a chart. Despite the fact that GraphQL Ruby has its own mechanism for authorization, the best solution is still to use third-party libraries that we are already familiar with. This solution will make it easier to migrate from one architecture to another and reuse the authorization code. However, we still have some wrappers and helpers that are specified to a particular architecture. We know pretty well these features for RESTful application, and also we have stable authentication and authorization libraries. And unfortunately, we cannot say that about the GraphQL ecosystem. There are many questions that are currently without answers. For example, how do we make an analog of the permitted attributes for GraphQL Ruby and authorize mutation arguments? Or how do we implement authorization for schema federation, which is more complex? Or on the other hand, there are good opportunities for open source contributions. And that's it. Thank you so much for being here today. I hope this information was of use to you. Feel free to reach out to me with any question or commentary. Also subscribe and read Martian blogs. And thank you and bye-bye.